Hello students, this is Dr. Abhijit Shah from Chemistry Department of SRM IST. In this video, I will describe the determination of ferrous ion using potassium dichromate by potentiometric titration. Actually, potentiometric titration means we can measure we'll measure the EMF of a reaction. When there is some redox reaction, oxidation reduction reaction, so in this reaction, the EMF of the reaction actually changing. EMF means electromotive force. Now, if we put some electrode in the reaction medium, so we can observe the EMF change of the reaction using an instrument called potentiometer. So in this titration, we are using ferrous ion and potassium dichromate. Ferrous ion means iron 2 plus, and potassium dichromate, it is an oxidizing agent. So in presence of sulfuric acid, this potassium dichromate oxidizes iron 2 plus to iron 3 plus. And this reaction, when this reaction is happening, means when more iron 3 plus is forming, the EMF of the shell increases, and we can measure this increase by a platinum electrode and using a potentiometer instrument. So this experiment, in this video, I will describe about this experiment. First, whatever I told now, that is the principle of the experiment. Next, I will show you one video. That video will tell you about this experiment, the principle, the apparatus required, the procedure, everything. First, you see the video, then we will discuss. This video you can consider as a virtual laboratory. So this is our video.
In this experiment, we determine the concentration of ferrous ions using potassium dichromate by potentiometric titration.
The aim is to estimate the amount of ferrous ions present in the given solution accurately using potentiometric titration.
Apparatus includes potentiometer assembly, burette, pipette, beakers, and electrodes.
The reagents used are ferrous ammonium sulfate solution, dilute sulfuric acid, and standard potassium dichromate solution.
Potassium dichromate oxidizes ferrous ions to ferric ions in acidic medium. During this redox reaction, the cell potential changes. This EMF change.
The given ferrous iron solution is made up to 100 milliliters in a standard measuring flask.
Exactly 10 milliliters of the solution is pipetted into a clean 100 milliliter beaker.
10 milliliters of dilute sulfuric acid and 100 milliliters of distilled water are added.
Next, immerse the platinum electrode and the calomel reference electrode into the solution and connect them to the potentiometer. Near the equivalence point,
standard potassium dichromate solution is taken in the burette.
So this is the values we are getting in addition of potassium dichromate. So next one is the fair titration. I'll talk about these things. Then this is the calculation part.
F rises sharply. The endpoint is determined from the midpoint of the S-shaped curve or the peak of the delta E.
Thus, the concentration of ferrous ions in the given sample is successfully determined by potentiometric titration.
In this
Okay, now I'll tell you the procedure. Okay, this is the procedure. Okay, so procedure already explained in the video. So what is the thing? Thing is we have to take the 10 ml of given ferrous iron 2 plus means mode salt solution. We have to add 10 ml of sulfuric acid. Then we have to add least amount of the water in a beaker. Then we have to take platinum electrode. Then we have to add potassium dichromate dropwise. Now this is two table, first table, second table. First table we will add potassium dichromate 1 ml, 1 ml, 1 ml like that, and then we'll get some graph. This is the one graph we will get from the titration 1. Now in this graph, this is the equivalence point, the middle part. Okay, so we know how much volume of the potassium dichromate required for to titrate this iron 2 plus solution. So based on this value, we'll make one. We'll do the second titration. In second titration, we'll call a fair titration. So in fair titration, we'll add 0.5 ml of potassium dichromate solution, and we'll get the graph in a derivative graph. Means delta E by delta V versus volume of the potassium dichromate. Here we'll get a peak. So that peak indicating the equivalence point. If we draw a parallel line to the y-axis, if we draw a parallel to the x-axis, parallel to y-axis, then that line will cut the x-axis at some point. That is the volume of potassium dichromate required to titrate the iron 2 plus solution. This value we have to put here, that is V2. And we know the normality of potassium dichromate, right? So based on this V1 N1 calculation, we can get the normality of iron 2 plus solution. Okay, next we can easily calculate the concentration using the normality. Okay, using this formula. Okay, thank you all for watching this video. Hope you have understood the experiment.